Okay, I just want to go over the different types of system of linear equations. And when it comes to identifying the type of system of linear equations, a lot of students of mine tend to be confused about the terminology of the system, so I want to go over that specifically. So let's start with the inconsistent. So the inconsistent type of system happens when you graph a system of linear equation given to you and you realize that two lines are parallel to each other. Well, since two lines are parallel to each other, meaning they don't intersect. When they don't intersect, we don't have any solution. In that case, your given system of linear equation is a inconsistent type of system because you have no solution due to the fact that there's no intersection of the two lines. So for example, in example 2 of in the video where I did my method of graphing, my two lines over here, when I graph them out, they never intersect. They're parallel all the way through. So because of that, I get to say this system of linear equation is an inconsistent type of system. Oops, that's a misspell right there. It's an inconsistent type of system of linear equations. And so graphically, two lines are always parallel. But algebraically, how do you identify whether a system of linear equation is inconsistent? Well, really, all you have to do is that you make sure you verify that the two slopes of the two equations are exactly the same. So in this case, they are -3/1 and -3/1. But the two equations have different y-intercepts. So one has a y-intercept of +2 and one has the y-intercept of +1/2. So because they have the same slopes but different y-intercepts, algebraically, I know right away that my system is the inconsistent type of system, meaning that it has no solution or no point of intersection. But what about the next type? Well, the next type is the inconsistent type. And for the inconsistent type of system, there are two subcategories of that. There's an independent and there's a dependent. Now, the independent consistent type of system is where you graph the two linear equations and they intersect each other at exactly one point. So this only point of intersection indicates that your system only has one solution. And because your system only has one solution, we say that your system is a consistent and independent type of system of linear equations. So for example, back to example 1 of graphing, now I convert these two equations to the slope-intercept form, denoted by capital A and capital B, and when I graph them out, they intersect each other at exactly one point. So I only have one solution for this system of linear equations. So this example, or this system I should say, is a consistent and independent type of system of linear equation. What about the next one? Well, the next one is a consistent and dependent type of linear equation system, because when I graph the system, I have two identical equations. And because two equations are identical, that means when I graph them out, both of the lines intersect each other infinitely all the way through. And because two lines intersect each other all the way, we say that our system has infinitely many solutions. And because they have infinitely many solutions, we say that our system is a consistent and dependent type of system of linear equation. And of course, if you're not sure about what I mean by two lines intersecting each other infinitely all the way through, just think of it as one line overlap the other. Okay, so one is on top of the other, and because of that, they always intersect each other. At every point all the way on your graph. For the consistent and dependent type of system, algebraically, if both of your equations have the same slope and the same y-intercepts, then yes, it will be a consistent and dependent.